So in this case, we are going to consider another typical exam question as we are preparing ourselves for the exams that are ahead of time we are given. Another Limpopo province that is from the Capricorn North District as our mathematics test for grade 9, and that was our term 3 test that we are going to try by all means understand the typical questions. So out of 75 marks, all right, so make sure that you go through the instructions, read each and every part to understand those instructions that you are given. So without wasting our time, we are going to quickly go through the questions. And before that, you must understand the basics of each and every part of your topic. So question number 1, encircle only the letter that correspond with the correct answer. On 1.1, we are given which one of these properties, take note, is not true. The one that is not true. Meaning to say the rest of the properties will be true, but one is not true. Which one? That is not true on the properties for a what? A parallelogram. All right. So if we understand, okay, let's see the first one. Opposite angles are equal. All right. This is a property of a parallelogram. As we do understand on a parallelogram, we stated that opposite angles, they are equal. All right. The angle that will be having here and this angle will be equal. The angle that is here and this angle, they will be equal. Okay, so this one is a property. It is true. Opposite sides are equal and parallel. It's a property of a parallelogram that we do understand. Opposite sides, they are parallel and also equal. It's a property. The diagonals, they are equal. Is it true that this diagonal and this diagonal will be equal? No, that is not a property. The property about diagonals is that they bisect each other. This one is divided into 2. This one is divided into 2. Not to say they are of equal length. So this one is not true. Interior angles sum up to 360 degrees. It's a quadrilateral, remember? So these angles, they add up to 360 degrees that are inside. So it's a property, again, of a parallelogram. So the one that is not is what? The C. Diagonals are equal. No, that is not. It is not like that. All right, 1.2. An equilateral triangle is a triangle with the two sides that are equal. No, that is wrong. We know that all sides are supposed to be equal. On B, a triangle with all sides that are equal. All right, so this one is true. A triangle with all sides not equal. Okay, that is wrong. A triangle with one angle equal to 90 degrees. That is wrong. We cannot have an equilateral triangle with 90 degrees. That cannot happen. To have 99, it cannot happen. All right, so the correct answer was going to be B. All right, moving on to 1.3, the equation of the straight line drawn below is, all right, so as we can see, guys, we dealt with this type of a line before, same points where it crosses or cuts the x-axis and also where it cuts the y-axis. Same line. So you see, guys, what I was saying, they do repeat these questions. So just revise as many questions as you can. All right. So here, it was corresponding like this. It was like this, which was corresponding. This was at 2. This is 0 here. 1, 2, 3, 4, and so on. This is -1, -2, -3. So we need the equation. The line crosses the y-axis at what? At 2, which is 0 to the y-intercept, and the x-axis at what? -2, -2, 0. So remember, we dealt same points, guys. We can determine the equation by having what? The points. So that's x1, y1, x2, y2. Remember, y is equal to mx plus c, where m is the gradient. The change in y over what? The change in x, our gradient. So that's y2, which is 0 minus y1, which is 2, over x2, that's -2, minus x1, which is 0. So that's a -2 over a -2, which was going to give us a 1. So guys, we dealt with this line exactly as it is. So y is equal to m, which is 1. So that's 1x, which is x, plus the c being the y-intercept, where the line crosses the y-axis at what? At 2. So c is equal to 2. So that's y is equal to what? X plus 2. Okay, so the correct or the proper answer that we were going to have there was going to be on B. All right, y is equal to x plus 2. All right, 1.4, if P is a point, all right, on a line defined by y is equal to x, then the coordinates of P are given as what? If y is equal to x, guys, it simply means that's the same thing. If we have got same value there, y and x is the same. So x is equal to y. So meaning to say, if x is 2, y is also supposed to be 2. So as a point, let's say x is given and y is given. It will be 2, 2 like this. For the value of x, it is the same as the value of y. So no matter the condition, if x is 3, it means y is supposed to be also to be 3. Same concept, same thing, because y and x, they are equal. Y is exactly equal to x, or x is equal to what? To y. So the point that can represent P is a point that has got same x and y values. All right, so the first one is wrong. This is minus, this is a positive. So this is totally wrong. This is a positive, a negative, it's wrong, a negative, it's wrong. This one is -3, -3. That's exactly what we want. So the correct answer was going to be D, where we have the same value for x and y. Y is equal to x. Take note, they can say y is equal to minus x. For this one, for the x value that you put, it changes the sign of y. If x is 1 and you put it there, y is equal to -1. So when it is y is equal to minus x, if x is positive, y will be negative. If x is negative, y will be positive. This one, it's a line for y is equal to minus x. But for line of y is equal to x, exactly the same. Exactly the same. All right. So guys, do revise. Do revise your topics. Each topic, those are your graphs. All right. 1.4, we are given which statement is true about fig below, right? Just given a line and another line. These two lines, they are not parallel. They are not parallel. There is nothing about parallel lines there. These two lines, they are not. We are supposed to be given proper lines that are parallel with indication of the parallel lines, that they are parallel. There is no indication. We are not also told. And even if you look, guys, these lines, they will meet at the end of them. They are not parallel. So meaning to say all these statements about corresponding angles is totally wrong, because these lines vertically, exterior, alternate angle, they're actually totally, because there is nothing about parallel lines there. All right, let's look at C. Angle A1 is equal to angle A3, vertically opposite angles. All right, this is true. These are vertically opposite angles, as we have got two straight lines which cut. All right, those are vertically opposite angles that are equal. Angle A1 plus angle A2 is equal to 180 degrees. It is very true that angle A1 and A2 gives us 180, but the reason they gave us is wrong. They are saying it is because of co-interior angles of a triangle. Is this a triangle, guys, here? There's no triangle there. Yes, we have got 180. Angle A1 plus angle A2. Truly, they give us 180 if we add these two angles. The reason being angles on a straight line. Angles on a straight line. So be very careful there. They gave us a wrong reason. So that's the best answer was going to be C. Correct layout of angles and correct reason. The statement and the reason is corresponding properly as we need this part. All right. Then on question number 2, state whether the following graphs are increasing, decreasing, or constant. All right. A negative gradient going down like this, that's decreasing. All right. Remember, guys, we talked about these ones. And here it is what? A constant here. And that's going up, increasing with a positive what? With a positive gradient. All these lines like this, they've got a positive gradient, here a negative gradient. So that's for 3 marks, all right? It was a direct question. On question 2.2, read the graph below and answer the questions that follow. So that was our graph having from 0, 1, 2, 3, 4, and so on, -1, -2, -3, our y-axis and our x-axis. So from there, 2.21, determine the coordinates of the y-intercept. Remember where the line crosses the y-axis, where it cuts the y-axis. So it crosses the y-axis at what? At 3. That's the y-intercept. The value of C is equal to 3. Remember, y-intercept. So as the coordinates, it will be what? It will be 0, 3. All right? Coordinates. So that will be 0, 3. 2.2, to determine the coordinates of the x-intercept, where it crosses the x-axis, where at what? -2, where it crosses the x-axis. This is our x-axis, where x is. So that's at -2. So x is -2. What about the y value? Y will be equal to 0. Remember, in the x-axis, the x-intercept, y is equal to 0. Y-intercept, x is equal to 0. Then 2.23, calculate the gradient of the graph. Calculate. You have the y-intercept, you have the x-intercept. Simply use these 2 points to determine your gradient. As we do understand that the gradient is the change in y over the change in x, meaning to say that's y2, which is 0, minus y1, which is 3, over x2, that's -2 minus x1, which is 0, all right? So 0 minus 3, that's -3. -2 minus 0, that's -2. So that was going to give us 3 over 2 as the gradient. Then determine the equation of the line in the form y is equal to mx plus c. As we do understand, y is equal to m represents what? The gradient. We calculated that m, 3 over 2x. C is the y-intercept. We have it there, 2.21. The y-intercept is at what? 0, 3. C is equal to 3 there. That's the y-intercept. So we have got that. Just substitute like that. So y is equal to 3 over 2x plus what? Plus 3. That was our equation. And another part, which is on 2.3, all right, there is, I think, all right, I think maybe just down here. All right, there's another part here, 2.25. They said, determine the value of y there if x is equal to 2. Show the value by marking on the graph as well and label the point A. All right? So first, let us find the point. They said if x is what? Is 2. It's a given condition on this equation. Put the x value in place of x. So y is equal to 3 over 2 times the x value, given that x is what? X is equal to 2 plus the 3. All right, so there we can simply use our calculator or just multiply here. This one and this one was going to cancel. That's a 1. 3 times 1, which is 3. And 3 plus 3 is what? Is 6. So y is equal to 6. That's the value of y. Meaning to say, as a point which is referred to as A, with the x value of 2, the y value of what? Of 6. We have got a point. Remember, x versus y, a point made of x and y. All right? So we are supposed to mark that point on the graph, 2, 6. From this graph, where is the point 2, 6? X is 2 and y is 6. So we go with these 2 up there and the 6 on y there. These 2, they meet here. Where they meet, that's a point. That's a point where the 2 meet. That's a point. So they meet here. You mark your point and label it A. That's the instruction. Mark that point and label it A. So guys, it was direct question like that. Then on 2.3, given this formula, complete the table below by using the given formula. Y is equal to minus 2x plus 1. How can we complete this table? We are given the x values, the input. What we need are the y values, the output. By inserting each and every x value into the equation in place of x. In place of x. So the first one, when x is 1, y is equal to what? Minus 2 times. In place of x, we put what? We put a minus 1. Plus a 1. Then we solve for that y. We can even use the calculator direct when it is like this, or we can just simplify it. Is up to you. Minus 2 times minus 1, that's a positive 2, then plus 1, which is what? Which is 3. Or you could have just used your calculator, minus 2, you open the bracket, minus 1, plus what? Plus a 1. This was going to give us what? A positive 3. The same thing when x is equal to 0. In place of that, you put a 0 there. You do the same thing, guys. You solve. You can just use your calculator, put a 0. So y is equal to what? A 1. All right. When x is 1 over 2, you do the same thing. Where there is x, remove that and put 1 over 2. So y was going to give us a 0. When x is 1, you do the same thing. In place of x, put a 1 there. All right. So we put a 1 that was going to give us a negative 1. So that was it. That's to complete the table. And after completing this table, we are now asked on question 2 point. All right, let's check the other part. Plot the points now. For the table above, which is the one that we did on the Cartesian plane below, and draw the graph. So we must mark those points that we are given. As you can see, this is 1, 2, 3, 4, 5, -1, -2, -3, and so on and so on. We mark those points that we are given. The x versus the y value. First one, -1, 3. When x is -1, y is 3. -1, 3 like this. X is -1. And y is what? Y is 3. So as you can see, they meet here. Where they meet, you mark a point. -1 and what? And 3 for y. All right? You do the same thing. When x is a 0, y is what? 1. That's 0, 1. X is a 0, y is 1. So where do we have the point 0, 1? Exactly on the y value in the y-axis, y value there at 1. You move on to the other point, it was a half and a 0. So it's half 0 like that. X value, that's a half. Y value, that's a 0. So half, that is 0, 5. Just in between. So we have got the x value at what? 0, 5. In between 0 and 1. So maybe just somewhere there, 0, 5. And the last point, 1 versus minus 1. When x is 1, y is what? Minus 1. So that's 1 and a minus 1 for y here. 1 in x, minus 1 in y. They meet here. Where they meet, you mark a point. So that was our point there. After that, join the points that's having what? A straight line by joining those points. All right? So that was the idea of the question. Plot the points for the table above on the Cartesian plane, below, and what? Draw the graph. So that's the graph of what? This formula. Y is equal to minus 2x plus 1. Y is equal to minus 2x plus 1. Just like that. So mark the points, then a graph can be drawn from there. All right, let's consider another part, which is question 2.4. Complete the table below. So there they gave us gradient, y-intercept, equation, y is equal to mx plus c. So this column is of the gradients going down like this. It's of the gradients. This column of the y-intercept, this one for the what? Equations. So here they are simply saying, let me show you guys what they are trying to say here. If the gradient is 4 and the y-intercept is minus 6, therefore the equation will be given as what? Y is equal to 4x minus 6. You substitute there, y is equal to mx plus c. M gradient. So that's 4, and the c is what? Minus 6. As you can see, that's the equation. So this one was not supposed to be 2.41. 2.41 was supposed to be here. All right, let me show you where the 2.41 was. 2.41 was this one. All right. So just like what we did on this part here, going straight like that. You follow that way. That way. You have gradient, you have y-intercept. Your equation is what? Y is equal to 4x minus 6. On the second part, we are given the gradient is what? Minus 5. The y-intercept of that line is what? Minus 8. Therefore, what is the equation of that line? As it is like this. So the equation is what? Y is equal to mx. M is minus 5. So that's minus 5x plus c. Our c, the y-intercept is what? Negative 8. So 2.51 was going to be y is equal to minus 5x minus 8. All right? And 2.42 there, considering this row like this, what are we given there? We are given the equation y is equal to 2x. Y is equal to mx plus what? Plus c. What is the c? If it is not given, it means that's a 0. So from there, 2.42 representing gradient. Remember, this is the part of gradient. So what is the m of this line that we are given as y is equal to 2x plus 0? So our m is what? 2, the gradient there. Coefficient of x. So m is 2. Then 2.43, the y-intercept. What is the y-intercept of this line? The c value. C is equal to what? To 0. The c is equal to 0. So you were noticing from what you are given. That's how you could have answered this question by analyzing this type of a question. You analyze the table, guys, the way that it is given, understand the illustration that you're given there. On question 3, consider the parallel lines. These lines, they are what? Parallel. We are told that. Consider parallel lines. We are told that. AB and CD, which is the line AB and CD. They are parallel. And they are cut by a transversal line GH. Okay, so consider these. The question now is 3.1. Find the sizes of the following angles with reasons. Whatever that you're supposed to give must be of reasons. 3.11, the angle W, right? So let's see, this is our angle W. How can we calculate angle W? Remember, we are told that these two lines, they are parallel. There is a relationship from the 110 degrees that we are given. It can give us the angle W. From which concept? We are forming a C like this. Remember, co-interior angles where we form a C. C angles, they add up to 180 degrees. Co-interior angles. So meaning to say, we can simply find the angle at W by subtracting this 110 from what? 180 degrees. 180 minus 110 degrees. We are talking about what? Co-interior angles. Since the given lines are parallel, AB is parallel to CD. So therefore, our W was going to give us what? 70 degrees. 180 minus 110, that's 70. So that's our angle W here. All right. So this angle here is 70 degrees. All right. Let's see another one. 3.12, angle Y. All right. Angle Y here. This is Y on the line. All right. That is where we are given our angle Y. Right, let's see. This is, guys, this is Y, this is Y. All right, W, there is an X there, there is a Y there. All right, W, X, Y, Z. This is supposed to be Y, this is supposed to be X. I don't know, the illustration that they just did there was just something else. All right, sorry for that diagram. So the Y that we are supposed is this one. So we are talking of what? Vertically opposite angles. This is our angle Y, this one. So to angle W, they are vertically opposite angles. So meaning to say angle Y is equal to what? 70 degrees. Angle Y is equal to angle W. Those are vertically opposite angles. If it is here. But if it was here, because here, according to the diagram, guys, as we can see, it was just something else. If it was here, you're going to use what? Angles on a straight line. You subtract from 180, or you can use alternate angles as you form a Z. So this angle was going to be 110 degrees where we form a Z. So your angle Y was going to be 110. So it's just that the way that it is given on the diagram, we don't know which one exactly was the angle Y, but you were going to answer anyway. Anyway, guys, they were going to mark you there. All right. So as for me, I'm going to take that other one. Then angle S on 3.13, angle S, which is here. So angle S and angle of 110 degrees, these are vertically opposite angles. Again, just like the Y that we had here, those are vertically opposite angles. So angle S is 110 degrees. All right, here we talk about what? Vertically opposite angles. So that's the same reason that you're going to write here, vertically opposite angles. All right, so those are the typical questions, guys, that you'll be given in your examinations, just revise as many questions as you can. 3.2, we are given to study this diagram. You must study it, understand what you're given, and answer the questions that follow. Given that AB, all right, so is parallel to DE. It was wrong, this one. They wanted to say BC here. BC, this one. BC parallel to DE. And angle D1 here, this one is equal to angle D2. These two, they are equal, all right? Determine the sizes of the following with reasons. So whatever that you're going to determine from this diagram must be backed up with reasons. All right, 3.21, angle D2. All right, angle D2. All right, so from our diagram, this is our angle D2 here. How can we determine that angle D2? Right? So first things first, the angle that is at D, the whole of angle D, is the sum of D1 and D2, because we are given that angle D1 is equal to angle D2. So we can find the angle that is at D, since angles in a triangle, they add up to 180 degrees. There is an angle at A, there is an angle at E, so we can find first the angle that is at D. The whole of the angle D is equal to 180 degrees minus the two angles, which is at A, 60 degrees and 70 degrees at E. All right, 60 degrees plus 70 degrees. So that was going to give us 50 degrees. So here we are using angles in a triangle. You know, they add up to 180 degrees. But we are given that angle D1 and angle D2, they are equal here. Angle D1 and D2. So if angle D1 is equal to angle D2, as we are given there, it simply means angle D2 can be calculated, because we simply have to divide the whole of angle D by what? 50 degrees. I mean the 50 degrees by what? By 2. These two angles, they are equal and they make up the whole of angle D. Angle D is a combination of angle D1 plus angle D2. So just divide by 2, which is what? 25 degrees. That's the angle D2. It is the same as angle D1. So if this is 25 degrees, D1 also 25 degrees. Remember, they're equal. But the whole of angle D being what? 50 degrees. So understand, guys. All right. So that's our angle D2. Moving on to 3.22. Angle C1, C2, and angle C3. All right. Let's see. Angle C1. This is where we've got angle C1. They are lines that are parallel. So what is it that we understand about angle C and angle E, where we form F angles corresponding? Angle C1 and angle D from the parallel lines. As you can see, we are forming an F. One is outside, one is inside the parallel lines. That's F angles, corresponding angles. So angle C1 is equal to 70 degrees. All right, angle C1 is equal to 70 degrees. There we are talking of what? Corresponding angles, since we are given those two lines that are parallel, BC and what? And DE. Remember these two lines, BC and DE. All right, we move on to another angle, which is C2. How can we determine angle C2? All right, we said C1, let's substitute. We say this is 7. It might help us, okay? So far, there's nothing. Okay, but remember, we said angle D2 is 25. From the parallel lines, are we seeing there a Z like this? Alternate angles, a Z is created. Alternate angles, C2 and D2. They are equal, alternate angles. Angle C2 is equal to angle D2. All right, angle C2 is equal to angle D2, which is what? 25 degrees. So the reason it's because of what? Alternate angles, Z angles, the ones that form a Z. Alternate angles. From the concept that these two lines, they are what? Parallel. Then thirdly, angle C3, right? So to find angle C3, what can we do? Remember, we have got angle C2 now, this one, at C2. We calculated, we say this is 25 degrees, same as what? D2. So how can we find angle C3? We can use angles on a straight line, which is okay. We can use angles in a triangle, in triangle DCE like this. Angles in a triangle, they add up to 180 degrees. You can use angles on a straight line. It is up to you. So as for me, I was just going to use angles on a straight line. Since I have C1, C2, I can find C3. So C3 is simply going to be equal to 180 degrees minus C1 plus C2, the angles that are on a straight line. So these are angles on a straight line. So there were two ways there. Could you have used that? Angles on a straight line. Or you could have used the concept of angles inside a triangle, co-interior angles, working with triangle DCE like this. These angles, they add up to 180 degrees. So any of the two, it was going to still give us the same answer of 85. All right. And on another question, angle B1 and angle B2, right? So let's look into the diagrams with the angles also that we have calculated before, right? We can simply work with the angles that we calculated before and see if they're going to make sense. Angle B1 and angle B2. Remember, all right, C3, we said 85, no problem. Let's see. B1 and B2, what can we do there? All right, let's start with B1. From the lines that are parallel, as you can see, we are forming F angles. B1 and the wall of angle D. F angles. So angle B1, if we check here, right, like this, F. Angle B1 and the wall of angle D. The wall of angle D. Corresponding angles where we form an F. So angle B1 is exactly equal to angle D. And remember, we calculated angle D. Angle D is the sum of these two, 25 plus 25, which is what? Which is 50 degrees. So that was exactly equal to 50 degrees. So we say these are corresponding angles. Since we are given the two lines that are parallel, BC being parallel to DE. All right, then what about angle B2? Angle B2 and angle B1, they are on a straight line. Two angles. There are only two on a straight line. And we do understand angles on a straight line add up to 180 degrees. So we're simply going to subtract the 50 degrees that we obtained for B1 from what? 180 degrees. So that's 180 minus 50 degrees, which was going to give us 130. So that's angles on a straight line. So that is the idea, guys. Just like that. You will be given these. There is reasons we've got. You have these reasons. On question number 4, calculate the size of angle A from this quadrilateral that we are given. We do understand that the interior angles add up to 360, sorry. This is a quadrilateral, so 360 degrees. So angle A will be 360 degrees. We subtract all these angles inside 90 degrees plus the 75 degrees plus the 68 degrees, everything that we are given. Angles in a quadrilateral. They add up to 360 degrees. So therefore, angle A was going to be calculated from there. So this was going to be, the whole part here was going to give us 233 from 360, which is 127 degrees. All right, that's for 3 marks to have that angle A. On 4.2, we are given in this triangle, LOV, the line OV was produced to E. And we are given that L to V is the same as L to O. They're equal, all right, from this concept. 4.21, calculate the size of angle L with reasons. The size of angle L. Remember that we are told that these two lines, they are equal, guys. And we do know that angles opposite equal sides must be equal. So if the angle O is 35, therefore angle V1 must be 35 degrees as well. The angle V1 must be equal to the angle O, which is what? 35 degrees. These are angles opposite what? Equal sides. Okay? So therefore, angle L can be calculated. Remember, angles in a triangle, they add up to 180 degrees. So angle L was simply going to be 180 degrees minus the two angles that are inside the triangle, inside the 35 at V1 and O there. So that's 35 degrees plus 35 degrees. 35 plus 35, that's 70. And 180 minus 70 was going to give us 110 degrees. All right. So the reason there for subtracting from 180 is what? Angles in a triangle. Remember, they do add up to 180 degrees. Then 4.22, calculate the value of y with reasons. The value of y. We have got y here and 35 degrees on a straight line. So y can be calculated, guys, angles on a straight line. So y is equal to 180 degrees minus what? Minus 35. We simply have to subtract the 35 from 180. Angles on a straight line. Just like that. All right? So meaning to say, this was going to give us the value of y. 180 minus 35. That was going to be 145 degrees. 145, okay? Classify with reasons triangle LOV. This triangle LOV, what type of a triangle is it? Where we are given two sides and two angles that are equal, guys. That's an isosceles triangle, right? So we are simply referring to an isosceles triangle. We have what? Two sides equal. Or you can talk of what? Two angles that are equal. All right. Then 4.3 in fig below, we are given that from C to S, it is parallel to the line HN. All right. These two lines, they are parallel from C to S and H to N. And we are given the angles of 70 degrees, which is the angle A, and also the two lines that are the same, AE and AW. So that was it. And also the angle X was given. Determine the value of X, this one, okay? The value of X. Remember, angle X is from the parallel lines, these two lines that are parallel. Angle X is equal to angle E2 from the parallel lines where we form a Z, alternate angles. It is equal to angle E2. So you must find angle E2. Angle E2 can be found from which concept? Remember, angle E2 and angle W1, they are equal. Angles opposite equal sides. These ones, they're equal. Angle E2 is equal to angle W1. We are talking about angles opposite equal what? Equal sides. So therefore, we can calculate these by taking 180 degrees, by taking this 70 from 180 degrees and divide by 2, because the two angles there, they are equal. So it was going to be 180 minus 70 divide by 2, which is going to give us what? 180 minus this is going to be 110 divided by 2, which is what? 55 degrees. So angle E2 is 55 degrees. Angle W1 is also 55 degrees. That is what we can tell from this. So therefore, angle X is what? Is 55, where we form a Z, alternate angles. So X is equal to the angle E2. Angle E2. We are talking about what? The alternate angles. Since we are given the line SC parallel to what? HN. Those are alternate angles. So therefore, angle X is equal to what? We have got angle E2, which is same as angle W1, which is what? 55 degrees. We calculated it. Which is 55 degrees. We have that. So therefore, angle X is what? 55 degrees. Revise, guys. As many questions. Revise. As many questions. All right. 4.4, there was no question on this one. It was just 4.4. I don't know what did they wanted to ask. What was the question? I do not know, guys. So there was nothing on this one. It was just an empty okay, just 3 marks for free. When it is like this, to be just nothing. All right, then let's see 4.5. In the diagram below, prove that triangle PTQ is congruent to triangle PTR. Give reasons for your answer. Remember, congruent figures, they're supposed to be a case of congruence. What is the case of congruence? That these two triangles, they are congruent to each other. We must work with the two triangles, analyze them. Triangle PTQ, this one, and triangle PTR. All right, let's try to analyze. From the two triangles, we can see that from these two triangles, the line QT is the same as the line TR. Remember, from that, we are supposed to prove with reasons. From Q to T or T to Q, it is the same as from T to Q. This is given, guys. We have angle there, common angle T for both triangles. From this one, PTQ is the same as the angle PTR. We are given this from our diagram. And there is a common side PT for both triangles. There's a common side PT. So we have side, angle, side. Side, angle, side. That is the case of congruence. That will make these two triangles to be congruent. Will be congruent to triangle PTR because of what? Side, angle, side. So that's the reason there. The case of congruence. As long you know the cases of your congruence, guys, it's just, this one is just a go-through question from your grade 8 mathematics. All right, 4.6. In fig below, we are given that the two triangles ABC is similar to triangle BDC. Then we have got these sides from A to B 12 centimeters, BC 5 centimeters, AC 13. Calculate the length of BD and round off to 1 decimal place. All right. Remember, I told similar figures. If two triangles are similar, I told you guys the first thing is to think of the ratio of sides from similar figures. We work with what? The ratio of sides. The ratio of sides is the same. AB over the corresponding side, BD, is the same as from B to C over the corresponding side, D to C, is the same as from A to C over the corresponding side, B to C. Ratio of sides. So the question is, we are supposed to find the length of what? BD. BD. All right? BD. Where is it that we have got BD? We have got BD on this part of the ratio, the first one. That's where we've got our BD here. So we are going to use the first one, with which one, another part which is complete. We have BC and DC. BC is given. What about DC? From D to C, we do not have. DC, we do not have. This one, it's not given. So let's ignore this one and move on to the other part. AC over BC. Are we having AC? AC is given. What about BC? BC is given. So we are going to take this other part. So the second part, there is something missing here. So we cannot relate to that. We are going to relate the first one to the last one where it is complete. We also have the AB. So you take AB, which is what? AB is 12. So 12 over BD, the one that we want to calculate, is equal to what? AC, we have that AC, 13, over what? BC. What is our BC? 5 centimeters. We have formed an equation from these ratios. So therefore, calculate BD. It's an equation. All right. So we're just going to cross multiply BD times 13. 13 BD is equal to 5 and 12. You multiply 5 and 12. That was going to give us a 60. So to find BD, we're going to divide by 13 both sides. Divide by 13. So BD was going to be 60 over 13. That's why they gave us an instruction to 1 decimal place. That's why there is an instruction. So to 1 decimal place, it was going to be 4,6, right? 1 digit after the comma, one decimal, 6 there. So 1 cannot change the 6. So it will be 4,6. It was given in terms of what before? These are centimeters throughout. So that's BC is 4,6 centimeters. Same units as we are given before. So those are the typical questions that you'll be given. You work out as many questions as you can. Make sure that you understand the basics of the topic. The basics. You will be able, guys, to answer any question. So prepare yourselves, guys, for the exams that are ahead of time. Till we meet again.